We're looking at probability. You've learned probability in the past. Today we're just kind of building on that. You've done what's kind of called simple probability, where you just find like the likelihood of an event. Like you roll a dice, what's the probability of landing on an even number, that sort of thing. Today we're going to kind of be building on that by looking at independent, dependent, and mutually exclusive events. Independent events are finding the probabilities of things that will happen, but they aren't affected by other things. Dependent is kind of the opposite of that. The outcome of your second event is influenced by the outcome of your first event. And then the mutually exclusive is where they are simultaneously cannot happen. Let's look at a simple example here. Let's draw a bag. And let's put in some marbles.
You guys have no imagination. I thought it was a chef.
All right. So the first thing we're going to look at are independent events. Independent means that it is not dependent on other things. So each outcome can kind of stand alone. I want to know what the probability is of drawing a red marble and then drawing a green marble. Now, when I say this is independent, what we're doing is we're going to draw out a marble, then we're going to put the marble back in, so we're going to replace it, and then we're going to find our second outcome. In order to find our red probability, we count the number of red marbles. There's 1, 2, 3 red marbles out of 1, 2, 3, 4, 5, 6. So 3 out of 6. Half the marbles are red. Green marbles, there is 1, 2 out of 6. So to find the probability of those happening, finding a red one and then a green one, we have to multiply those probabilities. 3 and 2 is 6, 6 and 6 is 6, reduce that to 1, 6. Numerator times numerator, denominator times denominator. Right, just multiply those two fractions together. Let's find the probability of two greens in a row. So we reach in, pull out a marble, put it back in, reach in, pull out another marble, and we want to know what's the probability of both of those being green. What's the probability of one of them being green? 2 out of 6, because there's 2 green ones and there's 6 total. So if the first one is 2 out of 6, the probability of drawing a second one is also 2 out of 6, and we just multiply those. One out of 9. And I like the way you said that. You said 1 out of 9. You didn't say 1/9. What this means is the probability is that's the number of times that we expect this outcome to happen in this number of chances. So if we performed this experiment 9 times, 1 out of the 9, we would expect it to have 2 green in a row. Is this experimental probability or theoretical probability? This is theoretical probability, right? We don't know for sure if that's going to happen. We are, in theory, that's what should happen, but that doesn't mean that it will always happen. A coin landing on heads is 50%. That's theoretical. We could flip a coin 10 times and it would land on heads every time. Possibly. So this is what we would call theoretical probability. 1/9, multiply straight across. 2/6 times 2/6 is 1/9.
So
And then you
I did
reduce
2
it.
times 2, then 6
Yeah.
times 6.
Yeah, and then you reduce it. So these are what are called independent events. Let's look at dependent. So we're going to change our experiment a little and make it a dependent event. Now, instead of putting the marble back in, we're going to leave it out. So we want to know, what is the probability of pulling a red one out and then leaving it off to the side, throw it away, and then getting a purple one. The purple one's probability changes because that first one that we pull out. So our first one is a red one. There's 1, 2, 3 out of 6. That probability doesn't change. However, our second one does. Because we pulled that red one out and we're leaving it off to the side. The purple one, there's going to be one purple one, but now instead of 6 marbles to choose from, there's only 5. So that probability this probability is dependent on this probability. So now we multiply those. Yes, Alex?
What if you don't pick a red?
This is our favorable outcome. So you're saying, well, if it's not a red one, then that wouldn't change it. What if we chose the purple one the first time? Then that would be 0. That's what you're saying, right? What this is saying is we want this to happen. What are the chances that this right here is going to happen? So we're writing our probability as if that is happening so that we can find that. So when we say that one of them is removed, this is only important if that's a red one. If that's not a red one, then this isn't an outcome that we're looking for. So we can only assume that that's a red one, and we can only find that information if that's a red one, because that's the only outcome that I'm interested in. So then I multiply straight across, 3 times 1, 6 times 5, reduce that fraction, and you get 1/5. Oh, no, 1/10, I'm sorry. So it should be 1 out of 10. 1 out of 10. So based on what you learned from this one right here, and based on what you know about dependent events, I want you to try and find the probability of pulling 2 red ones in a row if you are not replacing it. All right, who thinks they got it?
Ellen Triple picked it.
Lombardo, what'd you get?
1/6.
And how'd you get that?
I did 2 6 with it, which was the 2 reds out of the whole 6, and I multiplied it.
Well, hold on now. I got 1, 2, there's 3 reds in there.
Yeah, I know. Then I multiplied with 3 out of 6, which were all 3.
Okay, so the probability of pulling the first red one out is 3 out of 6, right? And now, if this happens, what's the probability of us pulling our second one out? 2 out of 5.
Oh, yeah.
Now, if we pull that first red one out, the probability is 3 out of 6 because half of these are red. The probability of pulling that second one out, our number of red ones goes down by 1, and the total number goes down by 1. So now we can multiply those. And when you do that, what do you get? 1/5. So what that says is that if I perform this experiment 5 times, I expect it to go red in 2 in a row, 1 out of those 5 times. Oh, waving. So our last criteria is if we're looking for multiple combinations. So like the probability of pulling out a green one or a purple one. In that last one, if I want to pull out a green one or a purple one, the probability of having a green one is 2 out of the 6. The probability of pulling out a purple one was 1 out of the 6. The probability of pulling either one of them out, you could think of them as like one possible outcome. So the green ones and the purple ones, a total, there's 3 there out of the 6. So you can actually add those together.
Would you still reduce it?
Yeah.
Okay.
Essentially what it's saying is you want green or purple, you don't really care, green or purple. Any combination of green and purple is what you're looking for.
And that one's the naturally exclusive one?
Yeah, and that's the one where you can just add up the totals.
Or put a little P on like the outside of the.
That's saying the probability of whatever's inside there. Mathematicians are kind of lazy by nature, so they just kind of come up with this shorthand. That means probability of whatever is inside that parentheses. Let's say you've got a dice,
I think probably, yeah.
and you've got this bag of marbles. What is the probability of rolling an even number and then drawing a green? Find that probability. So you've got a dice.
Just a dice.
Yep, just a single dice. So you got a dice in the bag. All right, so you've got, so Jessica was right, you got 1, 6. Now on your dice, you've got 1, 2, 3, 4, 5, and 6. Those are all of your possible outcomes on your dice. 6 sides there. So even numbers, 2, 4, and 6 are all even. So 3 out of the 6, which is half of them, are even numbers. The probability of pulling the green one out, you've got 2 out of the 6. So what you really do is you just multiply across. Honestly, we've learned enough about multiplication. You do not need a calculator for this stuff. What I would do is I would reduce. 3 over 6 is just 1/2. 2 over 6 reduces to 1 over 3. Multiply straight across. 1 times 1 is 1. 2 times 3 is 6. That's your probability.